Thanks for mathing with me today. In this video, we're going to talk about domain and range. Let's go over a little bit of vocabulary first. The domain of a relation or function is the set of all possible input values, usually represented by the variable x, and is the independent variable. The range of a relation or function is the set of all possible output values, usually represented by y, and is the dependent variable. Domain and range can be discrete and then written in set notation, or it can be continuous and written in interval notation. When it's possible to list all the values in the domain or range of a relation or function, that's when we call the range or domain discrete. So in these examples, we see that there are specific values of domain and range that we can list. We can list every single value of each of the domain and the range. So let's look at this first table of values. We see that the values of x in the table are 2, 4, and 6, which means that the domain is 2, 4, and 6. We list this in set notation because we can write them as a list. So we put curly brackets around our set of values, and each value is separated by a comma. Similarly, we see that we have the range values of 1, 4, and 9, and because we can list them all, we list them in a set separated by commas. And that set notation has curly brackets. Let's look at the graph. In the graph, in the middle of the screen, you see that all the values of x include 1, 2, and 3. So our domain is 1, 2, and 3. And similarly, our values of y that are included in the graph are 3, 4, and 5. So we list the range as a list in set notation, 3, 4, 5. Pause the video and try the third graph on your own. List the values of the domain and the range. Hopefully you pause the video and you see that the domain values include 0, 1, 2, and 3. And you see that 2, the value 2, is twice. However, we don't have to list it twice in our domain. Similarly, in the range, we see the values 1, 2, and 3 are included. And again, the values 2 and 3, we see them twice. However, we don't have to list them twice. It is enough to list them once. In these graphs, notice that it is not possible to list all the values because in between the points or the ends of the graph, there are infinitely many points included in both the domain and the range of these graphs. Because of this, we will use interval notation. So in the first graph, we see that when we look at domain, we want to move from left to right on the graph, and we want to see where does the graph begin from left to right. And we see that it begins here, which is the value 2. In this case, because it's an open circle point, it is not included in the domain. However, we list it as 2, and it gets a parenthesis because it's not included. And then as we move to the right, we see all these values are included. And then when we get to 5, that's where the graph ends. So this is the highest value in the domain. Because it's included, it's a closed circle point, so it's included, it gets a square bracket. So we notice that the domain is from the x value 2 to the x value 5. And so the lowest value is on the left, 2, and the highest value 5 is on the right. 2 gets a parenthesis because it is an open circle point and not included in the domain, and 5 gets a square bracket because it is a closed circle point and therefore included in the domain. Now, when we get to range, the range we see is from 2 to 8. And how we find that is we're looking for where does the graph start in the y value. So as we move from bottom of the graph to the top of the graph, we see that at the value y equals 2 is where the graph begins. So 2 is the first value in the range, and it is a closed circle point. Therefore, 2 is included in the range, and it gets a square bracket. As we move up on the graph, where does the graph end? At the top, we see that that y value is 8, and it is a open circle point, so it gets a parenthesis. So the range is from 2 to 8. It includes the value 2, so it gets a square bracket, does not include the value 8, so it gets a parenthesis. Let's look at the second graph. In the second graph, we have arrows on the end, and these arrows signify that this graph goes on forever and ever and ever past the coordinate plane that we see. So it goes on forever and ever here, and it goes on forever and ever on this side as well. Because of that, when we think about the domain that is included in the graph, it goes on forever and ever in the x value, negative x values. So it's going to go on forever and ever to negative infinity. And then we see that on this end, again, there's an arrow, so it goes on forever and ever on the right side as well, which means that infinity is the highest value in the range. Because infinity are kind of concepts and not really values that you can include in the graph or in the domain, they get parentheses always instead of brackets. When we look at the range, remember we're looking at the y values, and we just said that this graph goes on forever and ever and ever on the right side, which means it's going to forever go down, and it's forever and ever on the left side as well, so it's going to forever go down. Therefore, our lowest value in the range is negative infinity. As we move up on the graph, we see that the highest point on the graph is at y equals 6. And so 6 is the highest value in our range. And because it's included, it gets a square bracket. Pause the video and try the third graph. See if you can find the domain and the range on your own. Hopefully you paused the video and found that the domain, from left to right, we see the graph begins at x equals -2. However, it is an open circle point and gets a parenthesis. As we follow the graph from left to right, we see that it ends here, which is at x equals 4. And so 4 is the highest value in our domain and gets a square bracket because it's included. When we look at range, we are not looking at the ends of the graph. We're looking at where does the graph start from the bottom. So when we move up, we see that the graph starts here at y equals 1. So 1 is the lowest y value in the graph. Therefore, 1 is the first value in our range, and it gets a bracket because it is included. And then as we move up, we see that the graph ends over here, but it keeps going. There's more y values, right? All of these points along here have y values. And then when it ends, it's at y equals 9. And because this is a closed circle point, 9 is included. Therefore, it also gets a square bracket. All right, in this graph here, we see that we cannot list all the values of the domain. So if we're looking at the values of x that are included, right, we have all these infinitely many points in between each of these points that are included in the domain of the graph, and therefore the domain is continuous. However, when I look at the values of y that are included, I see that y equals 1 is included, and I see that y equals 3 is included, and I see that y equals 5 is included, but none of the values in between those values are included in the graph. Therefore, the range is discrete. So the domain we see begins at x equals 1, and that's an included point because it's closed circled. And then we continue here, and we see that part of it, the graph ends, this piece ends at x equals 3, and it's not included. However, when we go down to this part of the graph, we see that 3 is included. So essentially, there's no break in the domain. All the values to the left of 3 are included, 3 is included, and now these values to the right of 3 are included. And again, we have an open circle point at 5, which means 5 is not included here. However, it is included here, and all the points to the right of 5 are included. And then finally, we get to 7, and that's where the graph ends. And then 7 is not included, so it gets a parenthesis. So all the x values from 1 to 7 are included except for 7. And when we look at the range, we see that as we move up from the bottom of the graph, there's no graph down here. The first part of the graph begins here at y equals 1, and then there aren't any values in between here. There's no graph in between here until we get to 3. And then again, no values in between here until we get to 5. And so the values of the range are just 1, 3, and 5, and we can list them all. Therefore, we list them in set notation. So hopefully you learned a little bit about domain and range today. Remember that if you can list all the values in the domain or the range, you want to list them in set notation, which means it gets curly braces or curly brackets, and we list them separated by commas. If we cannot possibly list all the values that are included in the domain or the range, then we are going to use interval notation. Interval notation, we always write the lowest value on the left and the highest value on the right, separated by a comma. And then if the value is included, it gets a bracket, a square bracket. If the value is not included, it gets a parenthesis. Thanks so much for mathing with me today.